on your cold aisle configuration is what is permissible. The exhaust air temperature is irrelevant because as long as it's getting 80-degree intake, it can go and take this back out. And you can see the gradients on the right-hand side of what the temperature looks like. The varying height of ceiling. This is an example. I thought this was kind of fascinating that we did on the project. You can see it's a 10.5 foot ceiling height, and you can see to the left-hand bottom there's some hot spots being developed for this computing equipment array. You're looking at that in profile standpoint. But the customer said to me, hey, Mark, I got a proposal for $1.2 million of more incremental air conditioning equipment. He says to me, but what can you do? And I said, well, we can charge you. Obviously, that's what we can charge. We're a consultant and design engineer and builder and commissioner. So anyhow, we did a study, and we said, I said, we'll charge you for a study, which, by the way, was all based on the CFD model, and we can't guarantee what the results will be. You might need some more equipment. You might not need some equipment. Well, let's go to the next slide. We showed that if we varied the ceiling height to 12.5, 12.5 feet, by the way, we actually ran into some more problems with the heat load. As you can see, we actually compounded the problem. But let's go to the next slide. Look what happened when we went to a 16.5-foot ceiling. The thermodynamic impact of having a bigger cavity in the upper ceilings, and that's why, by the way, we're doing single-story buildings that are 22, 23 feet high. You could see that by the fact, and they actually had a cavernous area that they could increase the ceiling height, which we did for about $110,000 after the study was done, and in fact, they needed no more equipment. But that's the power of some CFD models. Let's see the CFD thermal analysis here. Here you can see a smaller data center with the shell, the floor, the crack units, computer room, air conditioning units, the PDUs, and equipment. Let's continue to populate that. Next slide. As you can start seeing here, just on the equipment orientation, you can see the equipment orientation shown is that the intake side of the units being blue and the exhaust side being red. It can be seen that not all equipment is orientated in a hot and cold aisle configuration. There are some front and back orientated. So just the basics of this was saying, hey, if I change some rack configuration because they actually had a mix of hot and cold aisle areas, they increased their efficiency.